Hey everyone! So welcome back. Looking at exploding dots. So we did the 2-to-1 machine, right? And we had here, right? Here is our 1 through 6, right? 1, 2, 3, 4, 5, 6. And here is what we got in base 2, right? When to count in base 2, you count 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and so forth, right? Anytime we had 2 dots, they exploded and became 1 dot, 1 place to the left. So if we're in now a 3-to-1 machine, is it any different? Well, no, it's exactly the same. But now instead of anytime we have 3 dots now, they explode and become 1 dot, 1 place to the left. So we could, instead of going, we could go one at a time like we did before, and 1 would be 1, 2 would be 2, 3, well, 3 would explode and become 1, so 3 would be 1, 0. Oh, well, in base 2, 2 is 1, 0. In 3, 3 is 1, 0. Huh. That's interesting, but let's take a look. Let's just start counting dots here. So here's 1, 2, 3, right? 4, 5. If I put a dot here, I can put a dot here. Now 5, oh, I actually put a dot, right? Whoops, I didn't mean to explode that. Here's a dot, okay. Right? So you have 1, 2, 3, 4, 5, but then here would be 8, right? Because this counts as 3. We're in base 3. So this is 3 to the 0. This is 3 to the 1. This is 3 to the 2, 3 to the 3, 3 to the 4, 3 to the 5, and so forth. Right? So if we start counting dots, we can put dots. If you put a dot here, maybe. Okay. How about 1 dot here and 1 dot here? What number did I just make? What number did I just make? Well, let's see. Well, let's explode our dots. First of all, we have only 1 dot here, 2 dots here, 1 dot here. But look, I have 1, 2, 3, 4, 5 dots in my first beaker. So 3 of those dots are going to explode. Kapow! And become 1 dot, 1 place to the left. That's, I think, all the exploding that's going to happen, right? Because now I have 2 dots here, 2 dots here, 2 dots here, 1 dot here. I don't have anything that has 3 or more dots. So I'm done exploding. And what number do I have? Well, I have 1, 3 to the 3, right? So what number did I just make? I made 1, right? And then I have 2, right? I have 2 dots in this beaker. So I have 1, 2, and then I have 2 dots here. So I have 1, 2, 2, and then 2 dots here. So I just made this number 1, 2, 2, 2, right? So this is my number in base 3. Okay, there's my number in base 3. Well, what number is that in the numbers that we're accustomed to in base 10? So, well, in base 10, right, where everything is in powers of 10. So this would be, again, this is our 1, so this is 2 to the 0. But this would be 2 to the 10. So I'd have, right, it'd be like 20. This would be 2, this would be, 10 to the first would be 10 squared. This would be like 200s, right? And this would be like 10 cubed, so 1,000. So I'd have 1,222, right? But is it 1,222 in base 3? Well, no. It's not. Because what this is in base 3, it is, what do we have? We have, let's start here. So we have a 1, but the 1 is in what column? It's in the 3 cubed, right? So what is 3 cubed? It's 3 times 3, which is 9, times 3, which is 27. So 3 cubed is 27. So that's the same thing as not 1,000, but it's like 27. Plus what? Plus 3 squared, so plus 9. Plus a 3, right? Plus 3 to the first, so that's plus 3. And then plus 2, because 3 to 0, this is like 1, and it's 2 1s. So it's 1, 3 plus 2 1s. So plus, or two threes. I'm sorry, two threes, right? I have 2 here. So that's 2 3s, and I have 2 9s as well. So I made a mistake here, right? Because we have 3 cubed is 27. This is like 9, but I have 2 9s. So I have 18. And then I have 1 3. I have 2 3s. I have 2 3s, right? Because this is my 3s, but I have 2 of them. So that's 2 3s. So that's like 6. And then I have 2. I have 2 1s. So this is what? This is 20, 30, 38, 40, 47 plus 6 would be 47, 53. Right? 53. So this number, right? 1, 2, 2, 2 is, so 53, the way we think of the number 50, if I put in 53 dots, I would get what? I would get 1, 2, 2, 2 in base 3. And again, it's exactly the same as in any other base. Let's quickly look at what happens in base 10. If in base 10, right? In base 10, if this was a 10 to 1 machine, we would count dots. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. That 10th dot would explode. That 10th dot would explode and become 1 dot, 1 space to the left, right? So what? So 10 is 10. And then you keep counting. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. What happens at 20? Well, 20, I have 10 dots. They explode and become 1 dot. They explode and become 1 dot. And now this is in base 10, right? So this is 10 to the first. And this is 10 to the 0, which is anything to 0 is 1. But this is, now I have 2 10s. So I have 2, that's 20. So 20 is what? Is 20. So again, we're accustomed to base 10. So these numbers are not going to change. We can count forever, and it's going to be exactly the same as the number we're accustomed to because we count in base 10. But again, in any other base, the way we count in any other base, I mean, 53. Well, this is 53 in base 3. Okay, it's not, and it takes a little getting used to, but it's not any more complicated. It's not like these other bases are, hard. It's not like base 10 is the best base to use, the most simplest base. I mean, kids maybe should learn to count in binary, because in binary, there's less to remember. There's only zeros and ones. In base 10, you're going to remember 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? In binary, there's only 0 and 1. Okay? You could count in base 0. I mean, you could count in just, zeros forever, and as many as you have, that's what you have, But, again, in any base, it doesn't change. And exploding dots, this is just the beginning. It really, it ties together so many different areas through algebra all the way up to into even calculus. And I hope to be able to make some videos that get there in the future. And look forward to those. Please like this video. Make sure to subscribe. The Global Math Project is going to be awesome. And I'll see you guys really soon. Bye-bye.